Hi everyone, this is Ranjit. Welcome to my channel. This video I'm going to explain about the cosmetic thread, which is an easiest tool in Creo. This is actually used for creating the thread profiles and to represent that in the engineering drawing. And sometimes it is used for interference checks. And the conventional method or the normal method, we need to use the helical sieve to create the threads, and it is very time consuming and you have to do all the jobs. For example, you have to specify the axis, you need to draw the cross section, you need to specify the pitch, height, everything. But this case, cosmetic thread, you can actually add some standard threads and it is an easy procedure. I will show you how to do that. So I'll open a new part. Then I'll go for a bolt creation, but when you go to assembly, there is one option, fastener, where you can have standard bolts, screws, everything available in the fastener. So you can drag it and you can fit it on the holes. So we are not talking about that kind of things. We are actually going to I'm just going to explain how we can apply cosmetic thread to a already existing cylindrical face. So I'm going to create a M12 bolt. So I'll use this extrude and I will select this plane and I will go to palette where I'll have a hexagon shape, and before that I need to use the sketch view, and I'm going to drag this hexagon here. Then I need to center it, so this is the center. Okay, then I'll close this palette, and inside the palette you have multiple sections and profiles, shapes. A lot of things are inside the palette. Just to check what are the shapes available in palette. If you are interested, you can check this palette. It's a very useful tool actually to create complex shapes in a very fast manner. So this case I'm going to change this into 12, because if it is a 12 hexagonal bolt, the side will be 12. Then I'm not going to follow all the nut profiles or all the bolt profiles here. I'm just drawing a hexagonal head and the cylindrical face. That's all. So this distance will be 12, and okay. Then I'll select this face and I will sketch, or you can directly go for the extrude. Then I'll draw a circle. Its diameter is 12 and I will drag it to 120. So this is my bolt and I'm going to represent the cosmetic thread here. If you go to engineering, you can see the cosmetic thread. So click on this cosmetic thread. It will ask you for the placement and depth. So I'm going to select this as my placement, and you can specify the start of the thread here. So I'm going to say this is the start of the thread. Automatically the thread is placed. I can control the distance. So I'm giving 70, and if you apply it, and you can also specify the diameter of the thread, pitch and everything here. And if you want a standard thread, you can go to standard thread and you can specify the standards, metric standards. This case it is 12, so I'm going to search for the 12. Yeah, M12 you can specify 1.5 that thread size. So this is my thread size. You can see it is approximately placed over the surface. Once you press OK, the thread is there, but it will be reflected if you go to the drawing. So I'm going to create a new drawing. I'll proceed with empty format, C format. Okay, and if I add the model, that is general view, if I add the model and if I change the display to wireframe and apply, I can see the thread here. So I'll make a standard view, front view. Okay, no, side view I think. Yeah, can you see the thread profile? It is actually nicely placed, and if you take the projection views, you can see the threads. If you change the view type into view display to wireframe or hidden, you can see the thread profile. If you change this into hidden, then the thread will be displayed as required by the drawing. So this is the way to create the thread profiles. This is very faster, and I have a separate video where I will explain how to do this in this thread with the help of helical sweep. Let me know if you have any doubts. Feel free to post your questions in the comment section. I will address them to the best of my knowledge. Don't forget to subscribe my channel. Press the bell icon for updates, and please share your comments and likes. They really encourage me to keep going, and I'm going to release a lot of videos related to solid modeling, simulation, structural analysis, computational fluid dynamics. Thank you.